The first question, okay, if B is magnetic field and mu naught is permeability of a free space, then dimensions of B by mu naught is, from definition of magnetic field intensity, what is the force acting per unit north pole is called magnetic field intensity at that point in a magnetic field, isn't it? Here, F is equal to what? From inverse square law, what is that? F is equal to mu naught by 4 pi m by d square, isn't it? Here, m are the two magnetic poles separated some distance apart each other. This is the first magnetic pole, this is the second magnetic pole. Okay, these two are separated some distance d in a space. Okay, so from this thing you can write like this, but F is equal to this thing. Therefore, B is equal to what? You can replace F by this thing. It means mu naught by 4 pi m squared by d squared by m. Okay, so 1 m is cancelled. Therefore, B is equal to mu naught by 4 pi m by d square, isn't it? Now B mu naught is brought into this side. That implies B by mu naught is equal to what? 1 by 4 pi into m by d square. Here to see, m is equal to what? Pole strength. M is what? Pole strength of a magnet. Okay, its units are ampere meter. Ampere meter. So 1 by 4 pi doesn't have any dimension. So m is equal to what? Ampere meter by distance is meter square. You can write dimension formula. A is equal to what? Current ampere. A meter length is L, m square. Meter square means L square. 1 L is cancelled. A into L power minus 1. This is the dimension formula for B by mu naught. Okay, right. The second question, statement 1. In a vernier calipers, one vernier scale division is always smaller than one main scale division. To see, in vernier calipers there are two scales. One is called main scale, isn't it? Main scale. And second one is called vernier scale. Vernier scale. Main scale is, in a main scale there are divisions, that means 1, 0, 1, 2 like this. Okay. If any object length is more than, okay, that means more than 0, that means more than 1 centimeter. Suppose it is move further like this. So how much distance it is moved, that is given by the vernier scale, isn't it? So 0 to 1, this is the 1 centimeter or 1 meter or whatever may be it. This is the main scale. Further, how much distance it is moved, that is given by the vernier scale. So that generally vernier scale is always less than, what is that? Main scale. So statement 1 is correct. Okay, next statement 2. The vernier constant. What is vernier constant? It is nothing but least count. Okay, what is the vernier constant or least count? What is that? One main scale division by, okay, number of divisions in vernier scale. Number of divisions, okay, in vernier scale. Vernier scale. This is the formula. This is the least count. But in the given statement, the vernier constant is given by the one main scale division multiplied. It is wrong. Okay, what is that? Vernier constant equal to one main scale division by number of divisions in the vernier scale. So statement 2 is wrong. So in the given options, statement 1 is correct, but statement 2 is wrong. Okay, this is the solution for this question. Okay, thank you. The third question. Two spherical bodies of same material, that means both are made up of same material, having radii 0.2 meter and 0.8 meter, are placed in the same atmosphere. So the first body is small. Its radius R1 is equal to 0.2 meter. Second body radius R2 is equal to 0.8 meter. Okay, these two are made up of the same material. Moreover, these two are placed in the same atmosphere. The temperature of the smaller body is, it is called T1 equal to 800 Kelvin. Okay, and the temperature of the bigger body is what? T2, 400 Kelvin. That means T2 is equal to what? 400 Kelvin. If the energy radiated from the smaller bodies, why? Because the body is above 0 Kelvin, so that it is continuously emits heat energy in the form of radiation from pivot theory of heat exchange. So, what is the heat energy emitted from the second body? E2 is equal to what? This is asking. Okay, moreover, assume effect of the surrounding to be negligible. That means the body is continuously emits heat to the surroundings because it is above 0 Kelvin, so it is continuously lost energy in the form of radiation. So the amount of heat loss, that means d theta by dt, is depends on its cross section area and fourth power of its absolute temperature from Stephen's law. Therefore, d theta by dt is equal to energy radiated from the body per unit time. So, which is equal to what? A into T power 4. Let me write E1 by E2 is equal to A1 by A2 into T1 by T2 power 4. Okay, here what kind of body is spherical body? So, cross section area of a spherical body is equal to pi r square. Therefore, E1 by E2 is equal to what? Pi r1 square by pi r2 square, isn't it? Into T1 by T2 power 4. So it may write simply E1 equal to what? E. E2 is equal to, if you want to calculate, is equal to R1 by R2 whole square into T1 by T2 power 4. Isn't it? Pi is cancelled. Therefore, E1 is equal to what? E. Therefore, E by E2 is equal to R1. That is of the first body, 0.2 by it has a second body, 0.8 whole square into T1 is equal to temperature of the smaller body, 800 Kelvin, means 800 by 400 power 4. It may write 4 times, it may write 2 times. 1 by 4 whole square, that means what? 1 by 16 into 2 power 4, 16. Cancel. Therefore, E1 by E2 is equal to 1. That implies E2 is equal to what? E only. That's it. Okay? Right. The fourth question, an amount of ice of mass 10 power minus 3 kg and temperature minus 10 degrees Celsius is transferred to vapor of temperature 110 degrees Celsius by applying heat. The total amount of work required for this conversion is. So first of all, what is given? Given mass of ice. What is that? M is equal to 10 power minus 3 kg. Initially it is a temperature minus 10. That means later it is transferred to vapor. So what happened here? First, ice is at minus 10 degrees Celsius. Okay. So first of all, it is changes ice at minus 10 degrees Celsius to ice at 0 degrees Celsius. Okay. So the amount of heat required. The body is at minus 10. When it is reaches to 0 degrees Celsius, it requires some amount of heat energy. That means the heat gained or lost by a body, okay, which is equal to say called delta Q1, which is equal to M into S into delta T. Okay, heat gained by a body or heat lost by a body. What is that? Q is equal to MST. So here, which one is loss heat? Ice. Gain heat? Ice. So what is given? Mass of the ice 10 power minus 3 into the specific heat of ice. What is that? 2100, isn't it? 2100 specific heat of ice, 2100 into change in temperature. What is that? Minus 10 minus 0. T2 minus T1. That means final temperature 0. Okay, minus of minus 10. They equal what? 10. Okay, so which is equal to 10 power minus 3, 2 zeros are cancelled, 1 zero is cancelled, then remaining equal to what? 21 joule. So this amount of energy required to convert ice at minus 10 degrees Celsius to 0. Okay, later it is changes from 0 degrees Celsius ice to 0 degrees Celsius water. This is called phase change. So at the time of phase change, the amount of heat required delta Q2 is equal to M into L, latent heat. Okay, latent heat of fusion. So mass is equal to what? 10 power minus 3. Okay, latent heat of ice. How much? 3.35, isn't it? 3.35 into 10 power 5. 1 0 is 2 zeros are remaining. So what? 335 joule. 335 joule. Later what happened? Later water at 0 degrees Celsius converted into water at 100 degrees Celsius. Okay, so the amount of heat required, delta Q3 is equal to M into specific heat of water into rise in temperature. So what is the mass of the quantity? 10 power minus 3, isn't it? Into specific heat of water. What is specific heat of water? 4180 joule per kg Kelvin into rise in temperature. 100 minus 0 is equal to what? 100. Okay, so it is remaining 418 joule. 418 joule. Later, water at 100 degrees Celsius is converted into vapor at 100 degrees Celsius. This is called a phase change. Again, the amount of heat required at phase change is equal to what? M into latent heat of, okay, latent heat of steam. Okay, latent heat of vaporization actually, LV. So M is equal to 10 power minus 3. Latent heat of steam is given. What is that? 1920. Isn't it? 19, not, what is it? Latent heat of steam. What is that? 2.25. 2.25 into 10 power 6 into 100 degrees Celsius. What is that? Into 100 degrees Celsius. Not required. Q is equal to ml. That's it. Why you can say? So what is the value? 2250. What is the 2250 joule? Okay, later water at 100 degrees Celsius converted into steam at 110 degrees Celsius. This is called, okay, this is called latent, the amount of heat required, delta Q5 is equal to M into specific heat of steam into, okay, into rise in temperature, equal to what? 10 power minus 3 into specific heat of steam. What is that? 1920. 1920 into rise in temperature, 110 minus 100 equal to 10. Okay, so which is equal to 19.2 joule, isn't it? So this amount of heat is required while ice at minus 10 degrees Celsius to steam at 100 degrees Celsius. Okay, so the energy required is equal to work done. Work and energy both and vice versa. So the total energy, that means delta Q net is equal to this one plus this one plus this one plus this one plus this one. So while you are calculating, we get 3043.2. 3043.2 joule. This is the solution for this question. The fifth question, a uniform circular disc of radius r and mass m is rotating about an axis perpendicular to its plane and passing through its center. Okay, a small circular part of radius r by 2 is removed from the original disc as shown in the figure. Find the moment of inertia of the remaining part of the original disc about the axis is as given above. To see, a uniform circular disc of radius r and mass m is rotating about an axis perpendicular to its plane. That means, suppose this is a disc which is rotating perpendicular to its plane about an axis. An axis is passing perpendicular to its plane. So it is rotating like this, isn't it? So the moment of about its center of mass. Okay, so moment of inertia of a circular disc. Circular disc. Okay, rotate about an axis. Okay, passing through okay, through its center. Okay, is equal to M r square by 2, isn't it? You know very well fact. Okay, I is equal to mr square by 2. Now what happened? A small circular part of a radius r by 2. Now from what happened? From this uniform circular disc, I would like to detach a small spherical, that means small, okay, sphere of radius is equal to what? R by 2 is detached. Okay, so what happened? Now this small circular part is rotate about a tangent. What is that? About a tangent. So moment of inertia of, okay, circular disc rotate about any tangent, okay, is equal to what? M r square. What is that? M r square, isn't it? But here the part, a small circular part of radius equal to what? R by 2. So what is the radius? R by 2. That means this is equal to R by 2 whole square. Mass is also changed, isn't it? Mass is also changed. What is that? So this part is supposed to be detached from this whole thing, which is this 1, 2, 3 and 4. That means mass is also divided by like this, m by 4 into r by 2 whole square, isn't it? Now what is asking? Find the moment of inertia of the remaining part. So after detached from this small part, what is the moment of inertia of this lamina about an axis passing through its center? That is asking. So moment of inertia of the remaining part. So what you can say, from total moment of inertia of the whole disc, from that subtract this part and this thing, then it gives rise to the remaining thing. So moment of inertia of the remaining part is equal to m r square by 2 minus, okay, so what is the part of this whole thing? M by 4 into r by 2 whole square. Actually this is divide by 2. Why? Because to say this part is rotate about center, but this small part is rotate about a tangent. So this this plus, what is that? M by 4 into r by 2 whole square. R by 2 whole square. So from whole thing you can detach this part and this part, then remaining part is obtained. So which is equal to what? M r square by 2 minus this thing, m by 4 r by 2 means what? R square by 4, 4 4 ja 16, 16 2 ja 18. That means m r square by 32, 16 to 2 32. Okay, plus m r square by 16, m r square by 16. Then you can make it do m r square by 2, which is equal to 32 when you take as a LCM. What is that? 32. What is that? M r square minus plus 2 into m r square, which is equal to, that implies, which is equal to what? M r square by 2 minus this whole thing, 3 m r square by 32. 3 m r square by what? 32. So from this I would like to take 32 is LCM. This is 32, 16 m r square minus 3 m r square, which gives rise to 13 m r square by 12. So this is the answer for this question. Okay, right. The sixth question, a bob of mass m suspended at a point O. So this is point O, a bob of mass m suspended from this point O, okay, by a light string of length L. The length of the string is equal to L, and left to perform vertical motion. So it may rotate in vertical motion, okay. Initially by applying horizontal velocity V0. After applying horizontal velocity V0, the particle, the bob of mass m is performing vertical motion on this circle, vertical circle, okay. The string becomes slack when the bob reaches at point D. Then it returns. Slack means what? Loses, okay, at point D. The ratio of the kinetic energy of the bob at the point B and C is equal to what? This is asking. Okay, So, once start its motion, the existing potential energy is converted into kinetic energy. With that energy, it reaches point B. Okay. Similarly, it reaches point C. Its kinetic energy changes while into potential while it reaches to point D, because from point D it slacks back, isn't it? So velocity gradually decreases and becomes zero. It possesses maximum. So potential energy at point D is equal to, and kinetic energy at point D is equal to kinetic energy at point C plus potential energy at point C. So by using law of conservation of energy, what is that? Total energy, that means potential energy at point A plus kinetic energy at point B at point A. That means total energy at point A is equal to total energy at point B. That means potential energy at point A plus kinetic energy at point A is equal to potential energy at point B plus kinetic energy at point B. Similarly, potential energy at point D plus kinetic energy at point D is equal to potential energy at point C plus kinetic energy at point C. Okay, potential energy at point A is equal to what? mgHa. Okay, plus kinetic energy at point A is equal to what? Of mva square is equal to potential energy at point B. To see, after giving horizontal velocity, it raises somewhat height h. So this is the total length L. So this is adjacent. So this length is equal to L cos theta. L minus L cos theta is equal to what? L. Which means it reaches to a point what? L by 2. Okay, after giving velocity V. Okay, so potential energy at point B is equal to what? mg position at B plus kinetic energy. This is required, kinetic energy at point B. So what happened? mg into 0, because A is the reference point. So height is equal to 0. So plus half m. Vm means what? Velocity at point A. In vertical motion, velocity at point A becomes maximum. What is it? 5gl. Root over 5gl. Whole square means what? 5gl. mg hb is equal to what? What height the body rises from A to B equal to what? L by 2. mg L by 2 plus kinetic energy at point B. So what happened? Which is equal to what? 5 mgl by 2 minus mgl by 2. This mgl also brought to this side. mgl by 2 is equal to what? Kinetic energy at point B. So what you get? 5 mgl minus mgl by 2 is equal to kinetic energy at point B. That means what? 5 minus 4. 4 mgl by 2 is equal to kinetic energy at point B. Therefore, kinetic energy at point B is equal to what? 2 mgl. Okay, similarly, total energy at D is equal to total energy at C, because after reaches point D, it slacks and becomes started transient. So potential energy at point D is equal to what? After rises, okay, mg hd plus kinetic energy at B, that means half m vd square is equal to potential energy at C. Okay, what is that? mg hc plus kinetic energy at C. So mg hd, what is the height with reference to reference point? This is L, this is L. So D point at a height of 2L. So mg into 2L plus half m vd. Vd is equal to velocity at highest point is equal to root gl. That means what? Root gl means whole square means root equal to gl. So is equal to mg hc. This is from reference point. Point O is at L by L. From and point C is also at L by 2. L plus L by 2. L plus L by 2 is the height of point C with reference to point reference point plus kinetic energy at point C. So what is that? mgl plus mgl by 2 is equal to what? 2L. That means 3L. That means 3 mgl by 2 plus kinetic energy at point C.
So it may write 2 mgl, that means 5 mgl by 2 minus 3 mgl by 2 equal to kinetic energy at point C, isn't it? 4 mgl minus 3 mgl, right? So what happened when you take this becomes LCM, okay, 5 minus 3, okay, what is the value you get? 2 mgl by 2 is equal to kinetic energy point C. 2 is cancelled, therefore kinetic energy at point C is equal to what? Mgl. What is asking? The ratio of the kinetic energy of the bulb at point B and at point C. Therefore kinetic energy at point B to kinetic energy at point C is equal to 2 mgl, 2 mgl by mgl, which is equal to what? 2. So kinetic energy at point B to kinetic energy at point C equal to what? 2. This is the solution. The seventh question, a small point of mass is placed at a distance 2r, this is a small mass m, placed at distance 2r, okay, from the center O of a big uniform solid sphere of mass m and radius is r, okay. So the gravitational force on m due to m, capital M is F. So the gravitational force on small m due to capital M of mass m, which is kept at distance 2r, is F1 is equal to gmm by r square, means what? 4r square. 2r whole square means 4r square, okay, right. Next, what happened? A spherical part of radius r by 3, suppose to see this is a big mass, from this its radius is equal to what? R. From this one I would like to detach a mass, okay, whose radius equal to what? R by 3, okay, detached. That means what happened? How much mass is detached from this whole mass m? What is that? M by this much times, cube times, that means 3 cube, that means equal to what? M by 27. If suppose if radius is equal to r by 4, which is equal to what? M by 4 cube, that means m by 64th mass is remaining, okay, okay, right. So that similarly radius is also changes. How many times? R plus r by 3 times. If suppose r by radius is equal to what? R by 4, r plus r by 4. So the mass remaining, okay, after detached r by 3 radius, so the mass remaining is equal to what? M by 3 cube, means M by 27, okay, and distance, okay, of distance shifted by center of mass of this bigger mass of mass m, distance is equal to what? R plus r by 3. If suppose r by 4 radius is detached, r plus r by 4, that means what? 4r by 3, okay. Now force on m due to remaining mass present in big sphere, say F2 is equal to this much, this total minus remaining. So what? gmm by 4r square minus gm mass. What is the mass is remaining? M by 27, gmm by r. What is the distance? 4r by 3, 4r by 3 whole square, okay. So that it may write gmm by 4r square minus gmm by 27 into 9 by 16 r square. So 3 times this is equal to 16, okay. So from this one I would like to take gmm by 4r square taken as common, 1 minus what is remaining? 1 minus in numerator 4r square, that means 1 by 9 by 3. 4r square. That means 4 3s are 12. 12 is remaining. Okay. Therefore, what is asking? The value of f1 is to f2. f1 by f2 is equal to f1 is equal to this much. GMM by 4r square into 4r square by GMM into this is go to 12 by 11. So this is cancel. Therefore, f1 by f2 is equal to what? 12 by 11. 11 by 12. Less, sorry, 11 by 12. Is equal to 11 by 12. So answer for this question equal to what? 11 by 12.
The eighth question. Two soap bubbles of radius 2 cm and 4 cm respectively are in contact with each other. That means there are two soap bubbles. Okay, its radius is R1. This is the second soap bubble. Its radius is equal to R2. But because first radius R1 is equal to R2 is equal to 4. That means first one is smaller, second one is bigger. Okay, these two are in contact. Suppose this is the small soap bubble in contact with big soap bubble. What happened? This is the area he is supposed to be in contact. In the question, the radius of curvature of the common surface. In the question, this is what is the radius of curvature of this common surface is asked. Okay, you know one thing. This is the first soap bubble. Its radius is equal to R1. So what is the pressure inside it? Say called P1. What is the pressure outside? Say P0. Similarly, what is the pressure in the bigger soap bubble? Say P2. Okay, outside pressure equal to what? P0. So due to excess pressure, what happened? P1 minus P0 is equal to what? 4T by R1. Why? Because from definition of excess pressure inside a soap bubble, what is it? P is equal to 4T by R, isn't it? So similarly, what is the pressure difference in a bigger? P2 minus P0 is equal to what? 4T by R2. Okay, due to surfaces in contact, so this is a common surface. So you want to calculate this value, common value. In this one, you should eliminate excess, that means outside pressure. That means this is subtract from this one. Therefore, P2 minus P0 minus P1 plus P0 is equal to 4T by R2 minus 4T by R1. Okay, so what happened? Minus P0 minus plus P0 cancel. So P2 minus P1 is equal to 4T by R2 minus 4T by R1. You know, this is the pressure, okay, difference between these two soap bubbles due to surface in contact. So which is equal to what? 4T by resultant, the radius in contact, R net. Contact radius, curved surface, radius of curvature, R net, equal to what? 4T by R2 minus 4T by R1. So on both sides, this 4T is cancelled. 1 by R net is equal to 1 by R2 minus 1 by R1. So you should simplify it. R net is equal to R1 R2 denominator, in numerator R2 minus R1 or R1 minus R2, whatever may be, no problem. Okay, right. So therefore 1 by from this one you should calculate R net is equal to R2 minus R1 by R1 R2, isn't it? 1 by P2, 4T by R2, right. So R2 is equal to given, what is the value? R2, 4 centimeter, 4 minus 2. Oh, reverse it here. R1 R2 by R2 minus R, isn't it? Okay, right. So 4 minus, that is equal to what? 4 into 2 by 4 minus 2. 8 by 2 is equal to what? 4 centimeters. So the contact, okay, the radius of curvature of the common surface in contact is equal to what? 4 centimeters. That's it. The ninth question. A particle is projected at an angle 30 degrees from horizontal at a speed of 60 meters per second. Okay, to see, this is graphically drawn like this. Okay, this is a body projected at a speed of what? With a speed of 60 meter per second. That makes an angle of 30 degree with respect to the horizontal. So the body is moved against the gravity, and finally its velocity is 0 at a particular point. That point is called maximum height. Okay, that is called maximum height. Then after it starts its return journey to reach the ground. This is the projectile. You know very well. So what is asking? The distance traveled by the body in the first second is h0, and the distance traveled by the body in the last second before it reaches the maximum height is h1. So what is the ratio of h0 is to h1 is? So first of all, you can take time taken to reach the maximum height, to reach the projectile at of its maximum height. Time taken by the projectile to reach its maximum height. To reach maximum height. Okay, what is that? Time of ascent is equal to what? U sine theta by g. U is equal to what? 60. Okay, sine 30 by g is equal to 10. So what will happen? 60 into 1 by 2 by 10 equal to what? 230. That means 3 seconds. That means the body reaches its maximum height in 3 seconds. Okay, work right. Next, what is the height traversed by the particle in the first second is h0. So in 3 seconds, the body starts its journey from 0 to 1 second. It covers some distance which is equal to what? h0. Next 1 second it covers some distance, and in the last second before it reaches the maximum height is h1. He is asking h0 by h1, isn't it? So time height, what is it? Height traversed. Okay, by the projectile. In the first second. The first second is from u sine theta plus a into what? N minus half. Equation of motion. The body covered in the nth second. Okay, so it is what? h0 equal to what? U 60 into sine 30 plus a is equal to what? Minus 10, because the body moves against the gravity, so acceleration equal to what? Negative into 1 minus 1 by 2. You get 60 into 1 by 2 minus 10 into 1 by 2, which is equal to 30 minus 5 equal to what? 25 meter. Next, what happened? In the first second is, and the height traversed in the last second before it reaches the ground. So what is the time? Third second. In third second it reaches the maximum height, isn't it? So height traversed by the projectile, okay, in the last second. It is what? N is equal to what? 3, which is equal to what? It is equal to what? Which is given h1 equal to same u sine theta plus a into n minus half. Therefore h1 is equal to, u means 60 into sine 30 1 by 2 minus 10 into n is equal to 3 minus 1 by 2, which is equal to 30 minus 5 by 2. That means 2 3 is 6 minus 5 by 2, 2 and 2 5. That means remaining is what? 25. What? 5 meter. Okay, what is asking? Therefore required. Therefore h0 by h1. Distance traveled in the first second. What is the distance? 25 meter by, in the last second, what is it? 5 meter. This cancel 5 and 5. So h0 by h1 is equal to what? 5. This is the answer for this question. The 10th question. The position vectors of two 1 kg particles A and B are given by position vectors RA bar and RB bar is given respectively. Alpha, beta and something are given, where T is the time, N and P are the constants. At time T is equal to 1, modulus of velocity A, that means magnitude of velocity of particle A and B. Okay, and velocities A and B of the particles are orthogonal to each other. At t is equal to 1 second, the magnitude of angular momentum of particle A with respect to position of particle B is root L, kg meter square per second. The value of L is, here L is the angular momentum. Okay, here therefore, what is finally L? Angular momentum of particle A. That means L is equal to what? M into R bar cross V bar. Here there are two particles. Moreover, in the question, the angular momentum of, the magnitude of angular momentum of particle A. So, mass of particle A, okay, with respect to the position of particle B, that means position of particle A with respect to B, okay, and velocity of A. So, here mass is already directly given, mass is equal to what? 1 kg, but position vector of particle A with respect to B, that means position vector of particle A is equal to alpha 1 t square, alpha 2 t j cap, alpha 3 t cap, okay, and position vector of B is equal to what? Beta 1 t I cap plus beta 2 t square j cap plus beta 3 t k cap respectively. So, here moreover alpha 1, alpha 2, alpha 3, beta 1, beta 2, beta 3 is given. Moreover, in this question there are some constants are there. What are those constants? Here to see, in beta value or alpha value, alpha is equal to 3n, beta is equal to what? 4p. So, we don't know the value of n and p. Okay, for that, for calculation of that one, you can use these two sentences. What is that? At time t, okay, what happened? 1 second, magnitude of velocity of particle A equal to magnitude of velocity of particle B. Moreover, those two are orthogonal. So, to use this sentence, you should calculate position vector of particle A with respect to B. Okay, this is required. Okay, but for calculating position vector of particle A with respect to B, okay, you can use this sentence. Okay, so what is the given? What are the given position vector of particle A? What is that? R A bar is equal to what? Alpha 1 t square I cap. Alpha 1 is given. What is alpha 1 value? 1. So, directly 1 into t square into I. That means what? T square I cap plus alpha 2 equal to what? 3n t j cap plus alpha 3. What is that? 2 plus 2 t k cap. Okay, similarly, position vector of particle B or B is equal to what? Beta 1. Beta 1 is equal to 2. That means 2 t I cap plus beta 2. What is the beta 2 is equal to what? Beta 2 minus 1. That means minus 1 t square j cap. Minus 1 t square j cap. Okay, next beta 3 is equal to what? 4p plus 4p t k cap. 4p t k cap. Okay, next what happened? Given at time t, any concept at t is equal to 1, what is the given? Velocity of, that means first you should calculate velocity of first particle VA bar is equal to what? Differentiate it, 2t I cap plus 3n j cap plus 2 k cap, and velocity of particle B is equal to what? 2 I cap minus 2t j cap plus 4p k cap. Okay, these are the velocity, these are the position vectors, and these are the velocity vectors of given two particles. Okay, at t is equal to 1 second, what happened? At t is equal to what? 1 second. What is the condition is given? Magnitude of velocity vector A, magnitude of velocity vector A is equal to magnitude of velocity vector B. So, VA at when t is equal to 1 second, V is equal to what? At t is equal to 1 second, velocity vector of A, what is that? 2 into 1, what? 2 I cap plus 3n j cap plus 2 k cap. Similarly, velocity vector B,
What is that? 2 I cap minus 2 t is equal to 1, 2 j cap plus 4p k cap. What is the condition? Velocity of wave. That means root over, what is the value? 2 square plus 9 n square plus 2 square means what? Directly you can write 4 plus 4 plus 4 is equal to velocity vector of b. What is that? 2 square means 4 under root 4 plus 4 plus 16 p square. Okay, and both sides square is cancel. So this square also nikal gaya. So what happened? This 4 cancel, this 4 cancel. That means 9n square is equal to what? 16 p square. 9n square is equal to what? 16 p square. 9n square is equal to what? 16 p square. Okay, 9n square is equal to what? 16 p square. Okay. Okay, so this is keep aside. Okay, next, this is equation 1. Next, another condition also given. What is that? And the velocities are orthogonal. If velocities are orthogonal, that equal to what? Their dot product equal to what? 0, because orthogonal means both are mutually perpendicular. Theta is equal to 90. So according to dot product, a bar dot b bar is equal to ab cos theta. Okay, so which is equal to what? 90 is equal to 1. So this b a bar into dot product of a vector velocity vector wave vector velocity and particle b velocity vector, both are 0. So that what happened? va, what is that? 2 into 2 4 minus 3 to the 6n plus 8p equal to what? 0. 8p is equal to what? 0. Isn't it? Now, to say from this one, I would like to take 2 becomes common. 2 minus 3n plus 4p is equal to what? 0. Isn't it? So, right. Now, what happened? 2 minus 3p is equal to 4p. Some from this one, I would like to take this 3n is go to take outside. 2 plus 4p is equal to what? 3n. Now, 3n value may be substitute in equation 2. Therefore, from 1 and 2, you may write 9n square means what? 3n into 3n is equal to 16 p square. 3n is equal to what? 2 plus 4p. 2 plus 4p into 2 plus 4p is equal to what? 16 p square. 16 p square. So what happened? 2 2 is 4 plus 8p plus 8p plus 16 p square is equal to what? 16 p square. On both sides 16 p square cancel. So what is remaining? 4 plus 16p. What is it? 4 plus 16p. 16p equal to what? 0. Isn't it? 4 plus 16p equal to what? 0. Okay. So 4, that means that implies p is equal to what? 1 by minus 1 by 4. So you got p is equal to what? 1 by 4. P is equal to what? 1 by 4. This value substitute in equation 1. Sub in 1. What happened? 9n square is equal to what? 16 into p square means what? 1 by 16. This is cancel. That implies n is equal to what? 1 by 3. That implies n is equal to what? 1 by 3. Okay. Right. Now n and p values are n and p values are obtained. So now these are substitute in velocity vector A. Therefore velocity vector A, why? Because you can calculate, you want to calculate angular momentum L value. So in this one we have to require velocity of vector A. Therefore VA is equal to 2 I cap plus 3n. 3n means what? 3 into 1 by 3 j cap plus 2 k cap. Therefore VA is equal to what? 2 I cap plus j cap plus 2 k cap. But you required position vector of A, particle A with respect to B. Okay. Now and RAB, position vector of A is equal to, you know what is that? Alpha 1 minus beta 1. Alpha 1 minus beta 1 into I cap plus alpha 2 minus beta 2 into j cap plus alpha 3 minus beta 3 into what? K cap. Okay. Therefore RAB is equal, position vector of A with respect to B is equal to what? Alpha 1 is equal to what? 1 minus beta 1 minus 2 into I cap plus alpha 2 3n, but n is equal to get 1 by 3. So 3 into 1 by 3 is equal to what? 1 minus beta 2 1 minus 2 j cap, isn't it? Plus alpha 3 is equal to 2 minus 2 minus beta 3 is equal to 4p, but p is equal to what? Minus 1 by 4 equal to what? Minus 1 k cap, minus 1 k cap. Therefore position vector of A with respect to B is equal to what? Minus I cap minus j cap plus k cap, isn't it? Is it correct or not? Alpha 1 minus beta 1. Alpha 1 is equal to 1, beta 1 is equal to minus 2, right? Okay, now we get the position vector and velocity vector. Okay. Okay, here to see 1 minus, it is not correct. What is? Because alpha 2 is equal to what? Alpha 2 is equal to 3 into n, means n is equal to 1 by 3, that means 3 minus 3 1. Beta 2, alpha 2, beta 2 is equal to what? 2. So what happened? It may get 1 plus 1 2. Okay, that means 1 minus of minus means plus 1. So which is equal to what? Plus 2j cap, isn't it? Therefore L is equal to mass of first particle is 1 into cross product I bar, j bar, k bar. Okay, RAB what? Minus 1 2 1 velocity vector A. You know, initially you get the velocity vector of particle A. What you get? Remember, 2 1 2, isn't it? 2 1 2 2 1 2. Okay. This is also alpha 3 minus beta 3. Alpha 3 is equal to what? 2 minus beta 3. That means what? Minus minus plus. That means it is getting 3r. 2 plus 1 3. That means 3k. So which is equal to what? 3. Minus 1 2 3. Minus 1 2 3. Right. Next it is equal to velocity vector 2 1 2. So which is therefore L is equal to I into 2 2 4 minus 3 minus j cap into minus 2 minus 6 plus k cap into minus 1 minus 4, which is equal to what? I cap minus 8 minus minus plus plus 8 j cap minus 5 k cap. Therefore, mod L is equal to root 1 square plus 8 square plus 5 square means minus 5 whole square means 5 square. 1 plus 64 plus 25 root 90. Yes. Therefore, L value is equal to what? 90. Okay, right. Thank you very much. The 11th question, three conductors of same length having thermal conductivity is K1, K2 and K3 are connected as shown in the figure. To see, this is the first conductor of thermal conductivity, coefficient of thermal conductivity K1. This is the second conductor of coefficient of thermal conductivity K2, and this is third conductor of coefficient of thermal conductivity is K3. Okay, area of cross section of first and second conductors are same. Okay, and for third conductor it is double of the first conductor. Okay, right. The temperatures are given in the figure. So this end is maintained at 100 degrees Celsius, the junction is maintained at theta degrees Celsius, and the second end maintained at 0 degrees Celsius. Okay, the value of theta is where in steady state condition. In what? In steady state condition. You know one thing, according to law of thermal conductivity, you know one thing, what is that? The amount of heat flow, that means Q by T, is directly proportional to difference in temperature between two ends, isn't it? And directly proportional to cross section area and inversely proportional to length of the conductor, isn't it? When you remove this proportionality, put a constant that is called coefficient of thermal conductivity. So it may write Q by T, that means rate of heat flow. Rate of heat flow, Q by T is equal to see, T1 minus T2 equal to change in temperature, that means difference in temperature, by this K into A take into the denominator, that means it equal to what? L by Ka, isn't it? So here Q by T is equal to what? Heat current. What is it? It is a heat current. So it is compared with electric current. What is that? Q by T, which is equal to what? Electric current. Similarly, this is called heat current. What is that? This is called as a heat current. So from according to Ohm's law, I is equal to what? V by R. V is the difference in potential between ends of the conductor, isn't it? By its electric resistance. So it is compared like this. It is equal to what? Delta T by R. Here R is the thermal resistance. This is what? Electric resistance of a conductor. Here R is the thermal resistance. So therefore R is equal to what? L by Ka. What is it? L by Ka. To see, the first conductor and second conductor both are in parallel, isn't it? Both are in parallel. So the resultant resistance of these two, what is that? 1 by R equivalent equal to 1 by R1 plus 1 by R2, isn't it? So R equivalent is equal to what? R1 R2 by R1 plus R2. Now this is in series with the third one of thermal conductivity, what? K3. So here we can write R1 is equal to what? L by K into A. But here to see, three conductors of same length having thermal conductivity is K1, K2 and K3 are connected as shown in the figure. Area of cross section of the first, second are same, and for third conductor it is double of the first conductor. That means R1 is equal to what? L by K into A by 2, which is equal to what? 2L by K into A. That means K1 into A, isn't it? Similarly, R2, thermal resistance of second conductor, what is that? Same, 2L by K2 into A. And third one, R3 is equal to L by K3 into A. L by K3 into A, isn't it? Now you can calculate, okay, at steady state. In the steady state condition means what? Same current. What current? Thermal current is travel throughout the length of the conductor, so that the difference in temperatures, what is that? Theta minus 100 by, these two are in what? Parallel. That means what? R1 R2 by R1 plus R2 is the resultant thermal resistance plus what is it, plus what is it, theta minus 0. This end at 0 theta degree Celsius, that end is at 0 degree. That means by R3 equal to what, 0, isn't it? When you substitute R1, R2 and R3 value in this given, then you can easily calculate theta value. While doing, we can getting theta is equal to what, 40 degree Celsius. Okay, right, thank you.